Our final colligative property is osmotic pressure, and unlike the previous three colligative properties, it doesn't directly deal with phase changes. Imagine a thin membrane that separates two regions of fluid. This membrane allows solvent molecules to pass through it freely, but blocks the passage of solute molecules. This type of film is called a semi-permeable membrane, because some molecules can permeate or pass through, while others cannot. Similar to our discussion of vapor pressure lowering, where the solute molecules at the surface reduce the rate of evaporation, solute molecules at the membrane reduce the rate of solvent permeation. And if we have solute on one side but not on the other, then the solvent flows reduced in one direction. When there is an imbalance in these two flows, there is a net pressure being applied. This process of flow through a semi-permeable membrane is called osmosis, and the net pressure resulting from the difference in solute concentrations is called osmotic pressure. Often osmotic pressure is measured in a U-shaped tube. The unequal flow across the membrane causes the volume to decrease on the side with pure solvent and increase on the side with solute. The height difference between the two sides applies an extra pressure downward on the side with the solute due to the weight of the extra liquid. Just by measuring the height difference once the pressures equalize tells us the osmotic pressure that is being applied across the membrane. The pressure, denoted with the capital Greek letter pi, can be calculated from the concentration in molarity, the ideal gas constant, and the temperature. Applying a greater pressure than the osmotic pressure can force the solvent backward through the semi-permeable membrane. This approach is known as reverse osmosis and is used for purification of drinking water. Osmosis is also a common phenomenon in biological systems because cell membranes are semi-permeable. For example, if you inject a solution into the body that has too low of a salt concentration, the osmotic pressure forcing water into cells will cause them to expand and burst. If you inject a solution too high in salt concentration, the cells will shrivel.